Welcome everyone to the next lesson of the microservice stack, and we come from a far way, right? We basically implemented a lot of services ourselves with our bare hands, with no external help from libraries and such. And I hope you could see how these things are being built, and we picked the aggregator as our core victim to add a lot of layers on top of that, like logging and instrumenting, and couple gRPC and JSON transports and mix them all together, make a client and all that stuff. So you know how that works. I explicitly did that first. So you know that making a service, even though the aggregator is very small, right? If you take a look at the aggregator here, can I please open it? Yeah, the aggregator. So it has a couple of files, not too shabby, but our service itself is basically just two functions, right? Aggregate distance and calculate the invoice. Of course, it has a store and everything. That's going to be perfectly fine, but it's in a memory store, so it's no big of a deal. But like this middleware needs to be implemented with these metrics, right? And then we have the HTTP stuff going on. We have the gRPC stuff going on. So you can see there's a lot of stuff. And of course, we need to do tracing, right? I talked about tracing in the previous video. If you want to add some tracing to that stuff, if you want to do rate limiting, client-side load balancing, which are also approaches, it's going to take a long time, right? And this is only one service. Can you imagine we need to do that for all of our services? That would be, then we are sitting here for a lot of hours. Of course, we are programmers, and in the programming world, there is some open source stuff going on. There are packages, there are libraries, and that's what we're going to do right now. We're going to pick our aggregator here, right? And we're going to redo the aggregator, but we're going to redo it with GoKit, right? Very important. I was a contributor to GoKit very long time ago, and I followed this project for a very long time. It's been a while since I do stuff with it, and I picked up a lot of the approaches that I'm telling you, like the onion layer and all that stuff is coming from Peter Bergen, which is the creator from GoKit. It's not that he invented it, but I stole that with my eyes, right? That's what we do. So now we're going to implement that with GoKit, right? So what we're going to do, I'm going to open up GoKit real quick so you can see what's going on. Standard library for microservices. Look at this beautiful GoKit thingy. It has everything, right? GoKit is a programming toolkit for building microservices or elegant monoliths. Wink. In Go, we solve common problems in distributed systems and application architecture so you can focus on delivering business value. Hey, seems like a good plan to me, right? So the goals is operate, yada, yada, RPC as the primary messaging pattern, pluggable serialization and transport, and all that stuff. And it has a lot of cool stuff built in. And we're going to do that, right? So you know that this exists and how they do it. They do it a little bit more enterprisey, which is good, right? Because I'm a sloppy person sometimes. Like I try to build stuff, I try to make things work, but at a certain point of time, we need to deliver some enterprise code. Let's do that right now. So the examples folder is probably, it's moved to this repo here. And we're going to open up the add SVC, which is going to be an add service. It's going to concat two things, I guess. So we're going to do, what's this, package maybe? This has a lot of stuff in it, guys, right? You have the add endpoint, the add service, and the add transport. Let's open up the ads. So you can see how they already basically, let me see if it's fine. That they split these things out. We have the endpoint, which is going to be some generic thing for transportation. Then we're going to have the service itself, which probably is going to have metrics and all that stuff tied to it. And then we're going to have the transport, which could be Kafka or Drift or something else, right? So that's what we're going to do. So we're going to open up the service first, and we see that we have middleware and service, right? So that's what we're going to do first. Let me show you. If we open up the service in GoKit, they do some kind of the same thing that we did, right? So they make a new service and all that stuff. They do some cool stuff here, which we're also going to do. And then they basically implement these two interface, which is the service implement sum and concat. And it's actually a little bit the same that we have with our aggregate, right? So without any further ado, let's get started. I'm going to speak from time to time into this repository because, like I said, hey, I know the basics, I know how to build stuff, but I don't remember every syntax in my head. So what we're going to do with this aggregator here, maybe we could do, let's make a new folder here. We're going to call this GoKit. let's say go kit example. Yeah, that could be fine. We're going to do this, boom. And then we're going to paste in a new file, which is going to be main.go, right? I'm going to say package main here, func main. It's probably going to take a couple of videos, not quite sure. We're going to see how far we come with this, right? So we're going to say service.go. We're going to say package main, of course. And we're going to say type service is going to be an interface, right? Just like that. And we're going to define two functions, right? If we take our aggregator here, aggregator service probably, service, boom, yeah, pretty fine. We can see that we have the kind of the same behavior. We have the aggregate distance and the calculate invoice. But we're going to follow the Go Kit principles, the Go Kit guideline, which is called this service, right? And we're going to have an aggregate function, aggregate, which will take in a context, right? That's how the professionals do it. That's what we should do. We don't have it in here, but we're going to have it in this GoKit implementation. It's going to take in the context, and we need a types distance in this thing. Types distance. We're going to return an error, right? The next thing we're going to do is calculate. And in our implementation, it was calculate invoice and aggregate distance. We're going to keep it the names a little bit shorter here. Again, we're going to say context, and this is going to be an integer, which is probably going to be the distance, I think. It's going to return a types.invoice and an error. All right, perfectly fine. Okay, let's kill this and this. So we have our service, beautiful. Then we're going to say, we're going to make a basic service. It's going to be a structure, and that will hold things for our, I think the store and such we need to do. And then we're going to make a function, which is going to be, I'm going to call this the new aggregator service. Wait, because this is going to be a little bit tricky here. We're going to do some cool stuff, I'm not going to lie. The new aggregator service, which will return, I'm going to comment this for you guys, because this is, like I said, this is the end exam, right? This, what we're going to do now with this aggregator, is going to be the end exam. It's the final rate boss, right? So the new aggregator service will construct a complete microservice. Yeah, a complete microservice with login and instrumentation middleware. Right? So this is going to return a new aggregator service with logging and instrumentation middleware. So that's 3 services, right? But it's going to return, I think, just a service here, all right? And what we're going to do, we're going to return null, because first of all, we're going to make a new basic service. Actually, to be honest, we can make this privately, a new basic service, which is going to take in probably nothing for now, and it's going to return a service. And in this case, it can return, I guess, the basic service. Not the new basic service, by the way. The basic service. What? Why is VS Code doing this thing? Basic service. God damn it. Just like that, of course. Then we're going to implement SVC, which is going to be as is fine. Actually, SVC maybe is going to be a pointer to the basic service. And we're going to have these functions implemented, right? So we're going to actually, to be honest, let's copy this, paste it in, join the lines. We're going to say underscore. We're going to mock the context, and we're going to say that the distance is going to be this thing. And then we're going to close this thing, return null in this case, right? Pretty fine. We're going to copy the calculate here, boom, and do the same shenanigans, right? We're going to say func svc basic service, paste that in, join the lines, and return double null actually here, right? We don't care about the implementation just yet. We need to say that it's going to be, it's also going to be a distance, right? Calculate the total distance probably. Is that? I think so. And it's going to be, let's mug that thing out. What do we miss here? A basic service. That's problematic. Guarantees basic service as value in return statement does not implement the aggregate pointer receiver. Is that true? Oh yeah, it's true. So we need to return the pointer, right? Boom. Just like that. Perfectly fine. That's that. So if we want to construct here the new aggregator service, which is basically the final boss here, we're going to say that the SVC is going to be a new basic service, right? And then the SVC is also going to be some other stuff, right? And let me open up so you can see this. So the new basic service returns this, right? Perfectly fine. But if we take a look at our middleware, according to GoKit, we going to add these things on top, right? And we're going to do it with a cool pattern, and I'm going to show you that. So that's what we're going to do now. We're going to make a middleware thing, and we're going to implement these little bastards here. And we already did that, right? It's not that different than we did. It's just going to make your life a little bit easier for adding all this other tooling on top of that. The new aggregator service. Wait, this is actually the new function here, guys. I didn't actually show you this. So let's open up. I cannot see where I am here. It's going to be the new thingy. Wait, where is that? Add service, service here. It's this, right? The new. It's going to make here a new basic service, a logging middleware, and an instrumentation middleware, right? So that's what we're going to do. And they make a nice cool thing with these scoping things, but I don't think it really matters in our case to do that fancy stuff, right? So what we're going to do here is we're going to make a new file, which is going to be the middleware, middleware.go, package main, type, I'm going to call it middleware, login, middleware, which is going to be a structure, right? That's going to hold a next, which is going to be a service, just like we did, right? We're also going to we're going to copy that, paste that in, and that's going to be the instrumentation middleware. Instrumentation middleware, which is going to be the same thing. And then we're going to say func new, can make it small caps, new login middleware, which is going to, instead that we basically return the service, which is perfectly fine, but it actually depends. If we do not, it's the same thing in Hollywood, right? It's the producer and the receiver function. If we are not going to take any arguments in here, we can actually return a service without any problems. But if we are taking arguments here, what we should do is we should make a type middleware, what they do, when what we actually should do is, and there should be a function. It's kind of a factory, to be honest. This middleware is kind of a factory, right? Because it's going to be a function that will take in a service, a caps service, and is going to return a service, right? It's kind of a factory. So instead of saying we're going to return a service, we're going to return a middleware here, right? So we need to return a function that will take in a next service and will return a service, right? And in this case, for a new logging middleware, what we are going to do is we're going to return the login middleware, the small caps logging middleware, by the way. And VS Code is not giving me a good time here, right? And we're going to say that next is going to be next, just like that. And if we want to provide our own logger, we could say, for example, log.logger, something like that, right? And yeah, maybe let's do that. That's actually cool. What we do with loggers, we don't need to construct it like that if you use loggers, but if you use a standard library or something, or maybe Zap, maybe they are compatible with this, right? So you can actually inject your own logger. The only thing it needs to do is implement the logger interface, which is, oh no, it's actually just a struct, to be honest. That's nothing good. So we're going to leave that open, right? Because otherwise we are depending on the standard library logger, and that we don't want that stuff. So we're going to return a middleware here. It's going to complain because let me open up service in the GoKit example real quick. I'm going to copy these two functions here, boom, just like that. Paste them below, delete this shenanigans, and I'm going to change this to WM from middleware into log middleware. Right, the same thing here. I'm going to change this to middleware, logging middleware. And we're going to do these two functions, so now everything is Gucci, right? We're going to do the same thing. We're going to copy this logging middleware and all of its functions. We're going to copy that. And we're going to paste that below the instrumentation. And we're going to call this instrumentation middleware, which is going to be this, the instrumentation. New instrumentation middleware, that's fine. Do we make some problems? Probably not. We're going to call this the instrumentation middleware and do the same thing here. Instrumentation middleware, right? Each time of, you can see that each type of middleware need to implement the aggregate and the calculate method. So now that we have this stuff, what we could do in service here, right? Each time we call a new aggregator service, we are going to say, you could do it like that. For SVC is going to be a service, and then you could say service is a new basic service. Service is going to be a new logging middleware service. We're going to give it this service here, and then we're going to paste that in, and we're going to say a new instrumentation middleware, and we're going to pass in the other service in here, right? Just like that, right? Making these onions, right? Let me quickly see if we make a mistake. No, that's perfectly fine. And then actually we could basically return the SVC here. Just like that, right? Look at this, beautiful, right? We could actually do like that, and you could return this also, right? It's the same thing, but I think this is a little bit cleaner. And what they do is they scope it in, right? They scope it in like that. Why? I have no clue. It's clean, right? This let's be honest, this is clean to see. This is, I like that. I like that stuff, right? So that's fine. We all have all that stuff. So what we need to do real quick is, are we going to implement these things right now, or are we moving to other stuff? I think our basic service aggregate, what are we using in our aggregator? Let me quickly see if we can replicate that real quick. Aggregator service this, boom, boom, boom. We're going to need a storer, that's fine. So what we could do here is say that we need a store, which is going to be a storer. Because we are in a new package, we can be in trouble here. Let's do that, doesn't really matter. Let's paste it in. It's going to be do insert and all that stuff. That's fine. Do we have some in-memory storage or something? Let me see. New invoice. We're going to do some copy pasting. I'm not going to lie. It's the store here. The problem is this aggregator is going to be a main package, right? You see? If you can see that, it's a main package here. So we cannot import this. So we need to basically, what we're going to do is we're going to copy this whole shebang actually. I'm going to copy this. Boom. Copy the whole thing and go to our GoKit example. We're going to make a new file. We're going to call this store go. Paste that in. And what we're also going to do, what I don't like, is the storage interface. I'm also going to delete that. Paste that in. Actually, what we could do is, no, I'm going to leave the code in. I was thinking maybe we should delete the old aggregator later on and take this instead, but let's just leave it in. It's fine. This is going to be a storage, right? Perfectly fine. Close some stuff up. Can I close all editors? It's fine. So let's go get example. It's going to take a storer here. And if we make a new basic service, we're going to say that the store is going to be a storage. So we can actually inject our storage just like this. Store, by the way, right? Perfectly fine. And then in aggregate, let me quickly open up aggregate service so we can see how we did that. So we have aggregate distance. We do some login, which we... Not quite sure why we do that. The only thing we do is return this one, paste that in. svc store insert distance. Dist. Was thinking. And for calculate, what we do here is we get the store, we return that stuff. So let's copy this thing, boom, 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 paste that in. That's going to be svc. Oh, it's the OBU ID. I see. I thought it was the distance. This is going to be the OBU ID. My bad. The OBU ID, that's fine. Oh yeah, that's what we do. The calculate is basically sending us calculate me the invoice for this OBU ID. So we're going to fetch it. Yes, that's what we're going to do. Okay, cool. I already see it. We need a base price. So that's very simple. We could copy our base price from here, from the top, paste that in because constants go on top of your file. Make a new basic service. You could make a new memory store here. And hey, we are good to go. So that's all set. So now we have basically what we need to have. We're gonna do this, return this invoice here, perfectly fine. Now we have everything, right? That's super cool. So what we're gonna do in the next thing we're gonna do is make our endpoints, I think, right? So in GoKits, let me see how long this video actually already is. The next thing we're gonna do is make our endpoints because now we have our service, so we are good to go, right? So that's fine. The next step we need to do is endpoint. So we go back to add service, middleware. We all did that stuff. Endpoint, also middleware. So you see, what they do is they take it a step further. That's what I was telling you, right? I was telling you that we have our middleware for our business logic, and then we had the HTTP middleware, which is basically a middleware around your transport, right? Around your endpoint, right? So that's what we're gonna do. Also, I'm gonna check here real quick what set is because I have no clue. Oh yeah, they make a set. Set collects all of the endpoints that compose an ad service. Okay, that's nice. It's meant to be used as a helper struct to collect all of the endpoints into a single parameter. Okay, I can feel that. I can feel that. And then we have a new, which returns all this. Oh yeah, they have a rate limit, and you can see it's crazy, right? They have open tracing, they have a trace server and all that stuff. They have Zipkin if needed. That's nice. So you can see this is enterprise stuff. Building this yourself is going to take a shit ton of time, right? All right, so it's going to be interesting, and we're going to do this with the aggregator service, right? If you do, otherwise it's going to we can basically marry together, right? If you want that, fine. But you're gonna, yeah, with all consequences that's coming from that, right? Let me quickly see here because I'm getting spammed by people. So some endpoint, concat endpoint, that's fine. So let's do the same thing like they do. So can I actually do something crazy that I never did actually like that? And I'm gonna take this example beautifully, like. Can you see this, guys? It's amazing. That's actually what we need to do. Of course, maybe the font is too big for that. We will see. We will see. Let's open up a new thing. They made it actually into endpoints. I think we're going to make everything in one file. Endpoint, go, boom. Package, main. Package, main. We're going to do the same thing. They make a set. I think it's interesting here. Let me zoom in if I can. Once more for the blind homies. Here. Type set. It's used to basically, because otherwise if you have 10 endpoints, you need to make probably in some other function, I don't know where, you're going to need to provide 10 arguments, and that's going to be sick. So they make a set. But they call this package endpoint, right? So it's going to be an add endpoint.set. Maybe what we're going to do, maybe we should do the same thing actually. I'm going to delete this. Maybe we should do a new folder and call this the aggregator endpoint. Aggregator endpoint, because that's what our service is. And actually what we could do is make a new folder and call this aggregator service. And basically take all of these things here. How do I do this? Like that. Put that into aggregator service. And the ag endpoint also, right? So now we have a GoKit example. And we have the ag service in here, which is this and the ag endpoint. And we're going to make a new thingy, and that's going to get called how do they call that? Set.go actually, right? Let's do the same. Let's do the exact same thing. Set.go package. That's going to be the ag endpoint. Boom. And we're going to say type set struct, right? I'm going to do this on the other side, guys, because otherwise it's getting a little bit too narrow, claustrophobic here. Man, this is actually insane. Boom, like that. All right, so we're going to have a set here, which basically going to collect a set of endpoints. So the first thing we need is basically the aggregate endpoint. All right, aggregate endpoint, and that's going to be an endpoint. Of course, now we are at the point that we need the GoKit standard library, right? So I'm going to keep this close. I'm going to open that up, and I'm going to say go get github.com, go get, is it git? I think it's that. Not quite sure. Let's press enter and hope for the best. It is. So we're going to do this. There's going to be an endpoint and save it beautifully, right? So we have an aggregate endpoint. We're going to copy that and we're going to say it's going to be a calculate endpoint. Boom, just like that, beautifully. Then we're going to make a new function, new, which is going to take in a couple of things. This histogram stuff, yeah. Let me show you this. Maybe it's good for you guys to take this next to you, that you can follow along. So this basically new returns a set that wraps the provided server, right? So let me open this up in big. They're using some open tracing stuff. We're going to keep it small, and then we're going to add stuff up, because otherwise it's going to be nasty, right? I like the way they do this scoping. I like that, right? So we need to do some and all that shenanigans. All right, it's fine. So let's keep new out of the way for now, because we need some functions here, which is the set. Some implements a service interface. Aha, that's true. That's nice, actually, right? Look at this. They actually make so nice onions, right? Because this set is also going to be a service. This is actually insane, to be honest. Not going to lie. They implement these two interfaces. That's what we're going to do first. Right? So we are going to do. The new is for later on. The first thing we're going to do is func as set. We're going to call this aggregate context, probably, yeah. The CTX is going to be the context.context, and then we're going to take in a types distance, which is going to be the dist here, and we're going to return, in this case it's just an error, right? Boom, just like that, and we're going to do this. We're going to return null here. Actually, no, we cannot return null. They say here that we need to make a concat endpoint, right? s.concat endpoint. Oh yeah, I see. That's this one. Okay. And we do is, oh, and it's taking the result. That's fine. Okay. That's interesting. So what they do is they say here that the response, which in our case is actually not for aggregate, because aggregate does not return, it only returns an error, but we're going to see how this is going to work out. It's going to be s.aggregate endpoint, and we need to pass in the CTX here, and then we need to do a request, which is an interface, which we now need to make, which is going to be the aggregate request, which is going to be a structure. And this aggregate request will take in the, well, it can take exactly the same thing that our types do, right? Because what types is business domain. I already covered this, right? So the types here is business domain. This distance is what your business logic needs to operate. The aggregate request, on the other hand, is what the transport needs to serialize it based on the transport mechanism, and then we need to massage that into our business logic distance. That's what's going to happen. So aggregate will take in basically these values, the exact same. If you really want, you can embed distance in here, but I think it's going to be a little, it's going to be the same thing. If you embed your struct distance into aggregate request, that's fine. We could do that, but it's maybe a little bit not so readable, in my opinion. So we're going to take in an aggregate request. Yeah, that's fine. So we're going to take in, this is actually so weird, right? We're going to take in these OBUID is going to be the distance.OBUID. And I know, guys, this sounds very complicated. This sounds very weird, but this is going to make sense, guys. Stick with me here. This is so important. OBUID, it's also going to have a value or something, yeah. Which is going to be the dist.value. And then we're going to have a Unix, which is going to be the dist.unix, right? It's just copying the same values, but it could be, for example, that our aggregate function just takes in one parameter, but that parameter needs to come from somewhere, and it's coming from your transport, right? It's coming from our transport, so we need to distinguish the request coming from the transport, which is different for each transport, right? This is for JSON, right? This is not for something else. And we need to map that to our business logic or domain data. That's that. So the question is, what are they doing here? It's going to be a response, yada, yada. Then they're going to say here, oh, we also need a response, which is actually nothing, right? But I'm going to make it anyway. Actually, to be honest, we're going to return here the error, right? Because our response for aggregate is nothing. So what I'm going to do is I'm going to quickly mug this, just like that. Because you're going to see if we make the same set for calculate, right? Calculate, which is going to take in this case, it's going to take in an OBUID, which is going to be an OBUID, which is going to be an integer, right? We still need to make, we're going to say s.calculate endpoint, and this is going to be a calculate request. This is going to make more sense for you. Calculate request, right? Let's make that real quick. Here, type calculate a request. There's going to be a structure, and this is going to be the OBU. I'm going to call it like that, OBUID int. What's going on here? JSON OBUID. Wow. You see that our calculate takes in an integer, but that integer needs to come from JSON. So we need to make a specific calculate request that can hold that JSON, that can serialize that thing. And then what we're going to do here is we're going to say response is going to be this one. We're going to say that it's a calculate request based on the OBUID, which is going to be the OBUID here, right? And we're going to say, is it doing something with these? Yeah. I'm missing something, guys. If the error is not null, then we're going to return the error. Actually, we could return error. It doesn't really matter, right? It doesn't really matter. I was right. What is this? Nothing. What is this? What is this thing? Unexpected context. Oh, yeah. Huh. What's going on here? This I never seen this. Probably missing a comma. I don't know what's going on. We're going to say if r is not null. This calculate returns the types invoice, right? The pointer even types invoice error, right? So we're going to say if r is not null, we can return null here and the error, right? On the other side, we're going to say that the response, we're going to the result is going to be the response, and it's going to be a calculate response, request response. Whoa. VS Code is making crazy shenanigans here. A little bit of lag. Calculate response. We don't have that, so we're gonna see it real quick here. Let me open up because it's getting make some endpoints. So what they do is these are the endpoints. They make the endpoints. I can see that. I can see that. This is the set. We wrap that thing. Concat endpoint. Perfectly fine. This is the concat response. I want to see what that is. It's so annoying, this GitHub thingy. Concat response. Man. It's V and this error. Yeah, I see what's going on. We also need to make calculate response. Let's make that real quick. Type calculate a response. Do they take errors in account? Yeah, that's what I thought. That's perfectly fine, right? So we're going to say it's going to take in the invoice, which is going to be a pointer to a types invoice. Actually, what we should do, because otherwise we need to do a JSON stuff in our invoice here, right? We already did that. Because this thing should be request or transport independent. In the, how do you write that? Independent. Should be transport independent, right? That basically means that JSON should not play a role in this thing, in this invoice. Because we're going to make, let me open up this types real quick here. We're going to basically copy this, right? Actually, the inner values. We're going to copy these inner values here. We're going to put them in here, delete that, because this is our calculate response. It's probably also going to have an error according to the docs, which is going to be JSON. Error is fine. Right, and the result is going to be the calculate response. It's probably going to be a pointer, not quite sure how they fix that. They're not using pointers, I guess, here. No, they don't. And then they're going to return these two things. It's fine. You need to understand that this, I can already imagine that it's going to be confusing for a lot of people. But there is a big difference between data, your business data, and data coming from a transportation. That's completely different. Although they can look the same, you cannot mix them together. Of course, if you're only using JSON, yeah, then it doesn't really matter, right? Then you can use the same set. But in our case, we don't, right? We can use thrift, proto buffers, message pack. We can use all that stuff. So we need to distinguish these two types together. Very important aspect. Like I said, we have a lot of content that we already did. Now this is basically the end exam. And I first did all that stuff so you could basically kind of get warm, because right now it's serious business. Right now it's serious business, right? If you understand what we are going to build here, which we already built, so you already have the idea of the aggregator. If you understand what we're doing here, then you're going to be a full-time GoDev engineer. It is what it is. So this is going to be the result, right? Which is going to be this calculate a response, right? Why do we need to assert? It's because this is returning an interface, right? So we need to say here that we're going to return a types invoice. So we're going to make a types invoice. We're going to say we're going to return a pointer to a types invoice and an error, which is going to be null. We return the error here. Actually crazy that it doesn't matter. I'm going to check that later on. So we're going to say the OBUID is going to be the result.OBUID. We're going to say that the, probably the is it the value? The total distance is going to be the result, the total distance. And then we're going to say the total amount is going to be the total amount. So you can see that these match together, right? So the request object and our business object, they match together, right? But it's not always the case, right? It's not always the case that they're going to match together, but here they match. Right, that's fine. So this is set up, right? This error is weird, declared and not used. Because we're going to return this error here, right? Perfectly fine. Fine. Let me open up back this thing, right? So we have our sum, our concat is basically our aggregate and invoice is being made. Now we need to make these endpoints, right? So I'm going to copy this. We'll knippen. It's not going to work, it's cut from GitHub. We're going to put that here, right? So this is going to be make, I'm going to delete this comments. We're going to say make aggregate endpoint, which is going to take in an it's also a little bit nasty. I'm gonna this is the ag service, this is the ag endpoint, and it's also going to be the service. A little bit nasty, not gonna lie here. This is a little bit nasty. How did they, where's this example here real quick? I'm just a little bit in problem with our they did, okay, they make it like that. Okay, so we're going to do the same thing. We're going to rename this. We're going to have some naming conflicts here. So that's a problem. Ag service, enter. Ag endpoint, we're going to make a new folder, and that's going to be the ag service itself, right? That's why we rename it, because we need to basically copy this. This may not go. We're going to delete that because we don't need it. We're going to say the store service and the middleware. So the ag service itself here, right, is acting as business logic, right? Kind of business logic with instrumentation and middleware and logging for the business logic, not for the transport, right? So this is going to be package service. Now we need to refactor this real quick. No, it's going to be ag service. Perfectly fine. We need to do it. Wait, what is going on? Did we just did something? No, store is fine. Middleware, ag service. Save this thing. Perfectly fine. And this is also going to be an ag service. It's all going to make so much sense when we are done with this, guys. This is your end exam. This is your end exam. This is... Yeah, this is completely right. It's going to be the aggregator ag service, save, perfectly fine. So we're going to say here, func response interface error, that's fine. It's going to be the request from here, fine, which going to be, in this case, an aggregator request. Aggregator request works pretty fine. We don't have any problem. We don't have any response coming except an error from aggregate. So remember that this S is going to be the ag service. So we're going to have here, instead of sum, we're going to have the aggregate thingy with a context. This is going to take in the rec. Oh, no, we need to make an types distance here, which will take in the OBUID, which is going to be the rec OBUID. It will take in a value, which will be the rec value. And it will also take in a Unix, which will be the rec Unix. So this is still going to be a little bit confusing here. But because we have we have the same types, but let's say that this aggregate function, guys, maybe our function was like that. Aggregate CTX, because I have a sense of things that are being unclear. Because if I didn't know this, in the beginning this for me was also unclear. So I'm going to emphasize this once again. Let's say that our aggregate function was something like this: OBUID, OBUID value and the Unix timestamp. Unix, right? Let's say our function was like that. So the only thing we needed to do to make that work is basically say rec.obuid, rec.value, and rec.unix. But we don't have that. Our aggregate function takes in a type's distance. So what we need to do is map the request type to the distance, to our types.distance here. That's what we need to do. I hope this is clear. I think this is going to be clear now. So we're going to delete this. There is a problem here, that's for sure. That's because error has already been mentioned here. So we're going to return a sum response. That's not true. We're going to return an aggregator. Aggregate response. We don't have that. We don't have an aggregate response because there is none. We're going to make one. Actually, to be honest, there is no response for aggregate, mon amis. So we're going to say it needs to return a response, right? Let's return null. They put the R inside of this thing. I see what's going on. We're going to make a response anyway. And I'm going to tell you why that is. We're going to make a response anyway because error is also a response, right? Aggregate request. So let's say type aggregate response, which is going to be a structure. And the only thing this is going to have is an error, which is going to be an error. And we're going to say in JSON format, it's going to be JSON error. Right, something like that, or error. Not quite sure how they call it here. What's going on here? Package, add point, set. This is going to be. They also call it R, I think. Where is this thing? Error. Yeah, fine. It's going to be an error. Okay, cool. So we are set. Aggregate response. So we need to return that here in our make aggregates endpoint here. We're going to return an aggregate response, and we're going to say that the error is going to be the R, right? Because if there is no error, it's going to be null, right? But we're going to return a response anyway. All right, that's cool. We're going to do the same thing here, which is going to be an ag service. We're going to say it's going to be in a calculate request. We're going to say service.calculate, which is taking a CTX and an OBUID, which is in this case going to be an rec OBUID. You see, in this case, it makes a little bit more sense. And we are going to return an aggregate response, which will take in an R, which is going to be the R. It will also take in, not quite sure, what does it take in? Calculate response, OBU total distance amount. Okay, fine. This needs to be calculate response, by the way. Calculate response. R is this. The OBUID is going to be the invoice. Invoice.obuid. Let me make it a little bit cleaner because I'm a little bit lost here also. Right, rec OBUID, let's save this. Then we're going to say that the total distance is the invoice.total distance. And we're going to say that the total amount is going to be the invoice.total amount. So you can see what's happening. We ask our business logic to calculate. We get this invoice thingy, and then we're going to return a response, right here. And that's going to be serialized in JSON. Let me see, where are we right now? I think we have implemented everything except our middleware, but we're going to try to test this all a little bit before we're going to add up to that. Yeah, let me see in my folder. Something is going on here and we don't know where it is. Nobody knows. It's VS Code probably or something. Oh yeah, fine. So we have our business logic set up. We have our logging. We need to implement it a little bit more, but we have everything set up. Our boilerplate is set up for our service. You can see it's a lot of stuff, but this is very, very nice, and it's an industry standard, and you should know that, right? In the next episode, we're going to continue this thing. We're going to build that, and you're going to see what amazing things we're going to achieve with that. See you in the next.